Alright, welcome back everybody. My name is Dustin, and in this video we're going to go over the challenge that I went over in the last video and create the RectFillTool. So the RectFillTool is going to basically be the same as the Create Tile tool that we have here. However, it's going to fill a rectangle that we create. So we're going to want to press the button, and as we drag, create a rectangle and fill in that rectangle with whatever tiles that we have selected. Okay, so let's quickly go over some theory of what we want to do. Alright, so let's go over how we want to create the RectFillTool. Okay, and this is one of the Tilemap Editor tools for Scion 2D. So basically, we're going to want to record when we first press the mouse button, and this will be our start position. Then with the mouse button pressed, we're going to want to slide the mouse to the desired position. And from there, we should be drawing a new rect with the number of tiles needed to fill that rect. This will give us 2 points right here, the start pause and the mouse pause, where we can calculate the width and the height of the rectangle. Getting the width and the height of the rectangle is a simple equation. So each point has an x and a y coordinate. We'll want to get the difference between the 2 points. So we'll call this float dx for the x coordinate. The dx is going to be the difference of the mouse position minus the start position. And this will give us the width of our rectangle. It's going to be the same thing for dy. So dy is going to be equal to mousepause.y minus startpause.y. That's all we need to do to get the width and the height. Awesome. So now we need to know how many tiles to create. So you have a tile. So say we have a tile. Each tile will have a tile width and a tile height. Since we already know the width and the height of the new rectangle to fill, we can easily calculate the number of tiles we need to create. So the first thing we're going to want to do is have a way to hold on to the start position and the dx and dy, or the width and the height of the rectangle that we have just created. And we'll do that by copying those values inside of a rect. Since we have our Scion rendering rect, we can just use that, create a member variable for the tile rect, and just take the position as the start position. The width is your dx and your height is your dy. Or you can call that width and height if you prefer. Like, so you could say float width is equal to mouse pause x minus start pause x, float height is equal to, or dx dy. It's up to you. Once we have the rectangle coordinates and the size recorded, we can easily draw the tiles with a nested for loop. Here is a simple representation of what we want to do. First, we loop through the y, which is the amount of rows. We will start at 0 and check to see if we are less than the rect height. Then increase our y based on the tile height. In the second loop, we will go through all of the columns. And inside of there, we'll be creating our new tile entity. And in here, we're going to want to check to see if there's a tile already there. We're also going to want to check to see if there's any necessary components that we're going to need to add. But we'll do all that later. Right now, we just want to get the tiles going to the screen. We'll worry about collisions and physics later on. So hopefully that makes sense. All right, so that was just a quick overview of what I would like to do. There's a bit more to it when we actually start to code. For instance, one of the part of the challenge was to be able to drag the mouse in any direction. So we'll have to be able to handle the cases for that, but we'll go over that when we get there. All right, let's get started. All right, hopefully that was helpful of what we plan to do in this episode. So right now, the first thing I'm going to want to do is create the RectFillTool class and base that off of the tile tool. So let's go into our editor and let's go to our tools. Inside of our tools, we can create a new file, and we'll call this the RectFillTool or RectFillTileTool, or it's up to you. .h. And yes, we want to add it. All right, and we're going to add our pragma once and our namespace. That's just Scion Editor. Editor. Cool. And we're going to want to include the tile tool because that's going to be the parent or the base class for this. So tile tool. Cool. Now let's create our class. So that's just class RectFillTool public tile tool. Cool. So we're going to have some private variables that we'll get to and some public. So, alright, for the public functions, all we really need is the constructor and the destructor. The rest of the functions, besides the create and draw functions that we need to override, those can all be private. So for now, let's just add in our RectFillTool constructor and the destructor. And we're going to have to put in our 2 overrides, so virtual void create. That's an override. And our draw. Okay, let's create these to start. Actually, before that, let's actually just create our RectFillTool.cpp. So add new file, RectFillTool.cpp. Yep, I want to apply it. Include RectFillTool.h. Namespace Scion Editor. Cool. Go back here. Okay, now that we have our CPP file, let's create all these functions. It should create them for us. All right. Cool. Okay, so let's go up to these private variables and add a couple variables that we're going to need. If you remember, we're going to need to be able to draw the rectangles. And for that, we can just use the rect batch render that we created before. So let's forward declare that. And that was namespace Scion rendering. And inside of there, I'm going to want to say class rect batch renderer. Cool. KD. And here we can make a unique pointer. So std unique pointer to Scion rendering rect batch renderer. And that's just going to be our p shape renderer. Cool. Or you can just say rect renderer. As for holding on to the rect position and size, we can use the Scion rendering rect. We went over that slightly in the slides there. Or if you feel like it, we can create our own for the tools themselves. But for now, we're just going to use what we already have. If we go quickly to our rendering, and then we have inside of here, inside of our rendering, we have the include, I believe it's essentials. And then in our primitives, right here, we have the rect. We can just use this because it has everything we need. It does have a color. We don't really, well, we can mess with the color, but we don't really care about it for this particular situation. But it has everything we need here. Okay, so we have our position, our width, and our height. That's what matters the most. So I'm going to want to use that, and we can actually forward declare that as well. And that is just the rect here, and that's a struct. So we can just say struct rect. Cool. And that can be another unique pointer. We can actually just copy this down because it uses basically the same and just use the rect. And then we'll just call this the MP tile fill rect. Tile fill rect. Cool. And the last thing we're going to need is we need to be able to hold on to the start position. So let's create that. So that's just going to be glm vec2 m start press pause. Cool. All right, so now that we have those, let's go into here and check out our constructor. And we're going to want to do the tile tool. And we're going to do the MP. See, we have the batch renderer. We don't want that. We want the shape renderer. And we're going to have to include that. Include rendering core rect batch renderer. We're also going to want to get the primitives. Rendering essentials primitives. Cool. And we might as well add a few other things over here. We might as well add the main registry. So core ECS main registry. Include. We're going to need the asset manager. So core resources asset manager. Might as well get the logger. Logger.h. Cool. And we can start with that. So we have our shape renderer, and that's going to be std make unique. Scion. Actually, up here, let's just using namespace Scion rendering. I'm going to add another one, and this one's going to be core ECS because I know we're going to be using that. Cool. So here I can say make unique rect batch render. Cool. And then we can do the tile fill rect. So MP tile fill rect std make unique. And that's just a rect. A few ways that we could do that. We want to highlight it and make sure it's the rect that we want. Scion rendering, yep. Cool. That's all we need for that. And our start position can just start off at 0. M start press pause 0.f, not f.f. Cool. Nothing to really do in the constructor or the destructor, sorry. All right, let's quickly go over the create function. So the first thing we're going to want to do is check to see if we can actually create the tiles, okay? So we're going to want to make some quality of life fixes here. We have our tile tool, so we can go here. Let's go to our tile tool. And we have a few things that we can do. I want to check to see if the sprite is valid. We want to check to see if the tool is activated and all these other things. So we might as well just add a new function here and just say const bool can draw or create const. So let's make this function. Rather than putting all these in each single line, we can just do it one time and call it each time we need it, okay? So what we're going to return here, well, first thing I want to check to is, are we activated? So is it activated? And, not stars, and we're not out of bounds. And are we over the tile map? So is over tile map window. And is our sprite valid? Cool. So we'll just use this. Now go back to our fill rect and say if not can draw or create, we can just return. Cool. Now this is where we want to set the start position. So we go if mouse button just pressed, and I can say E mouse button left or right. So because we want to do both, because the start position needs to be for the deleting as well or removing. So if either one is pressed, then we're going to want to set our start position. So M start press pause is equal to get mouse world chords. Cool. Now we want to check to see if the previously pressed mouse button has been released. If it is the left button, we want to create the tiles. If it's the right button, we want to remove or delete the tiles. So we can say if mouse button just released, then we're going to say E mouse button left, not last, left. And we can just copy this line down and say right. And this can be else if here. Cool. So we have some to-dos to do in here. So we're going to need to create two more private functions, one for creating tiles and the other for removing tiles. So we might as well do that now. So we can say create tiles, and then we'll have another one right here that's remove tiles. Now we could do it all in this function, but I'd rather separate them. So let's do that now. So let's take this one, go back to our fill rect, and we'll create a new private section for the functions. I like to do that. You don't have to. Whoops. You don't have to do this, but I find it cleaner. And it's just going to be void. And we can copy this down, and this can be remove. Or call it delete. It's up to you. And we're going to want to create these. And you know what? We might as well create another function, and that's going to be for the drawing preview. We're just going to create the function for now, and we'll fill it out later. So draw preview is going to be its own function. Cool. Now that we have the create function somewhat done here, let's go to the draw function and quickly go over that. So the draw function is going to have the same thing with the can draw or create. We'll take this. This check can be in here. There's no need to do it if we can't. Okay. Now we want to get the basic shader from the asset manager. This will be used to draw the tiles themselves. So we can go auto p shader is equal to main registry dot get asset manager dot get shader, and it's just going to be basic. Then we want to check to see if it's a valid shader or not. So if p shader, and that's if not, make sure we put that in. We're just going to return. Okay. Then we're going to want to enable our shader, set the matrix, then draw the mouse sprite. Basically the same idea that we did in the create tile tool. So p shader enable. Let's get the camera matrix. Camera mat. Not auto. Cam mat is equal to mp camera get camera matrix. But we don't know what a camera is. So if I go, nope, it's not letting me see it. So up here in our rendering, we're going to want to get the camera as well. I think that's correct. Now that we have the camera matrix, we want to set that in our shader. So P shader, set uniform map 4, U projection, cam mat. Cool. And from here we can draw our mouse sprite. Draw a mouse sprite. Awesome. So we always want to draw our mouse sprite, but if neither buttons are pressed, like either the mouse button left or mouse button right, we just want to leave. So let's create two bool variables. So bool B left mouse pressed, and that can be mouse button pressed, E mouse button left. And we can copy this down, change it to right. Cool. So if not B left and not B right, return. Awesome. So this will just leave, we'll leave if we're not actually pressing the button right now. Not just press, we have to be pressing it, okay? So now we want to do the width and height calculations. We basically want to do the same thing that we did in the slides, or that we went over quickly in the slides. There will need to be some adjustments later, and we'll go over them later and when we get to it. I want you to see what happens. So we want to first get the mouse coordinates. So we want to do const auto mouse world coords is equal to get mouse world coords. Now, do we need to be a reference here? No. So it doesn't return, oh wait, it does return a reference. So yeah, so we might as well use the reference there. Let's get rid of that. Cool. Now we want to do the auto dx is equal to mouse world coords dot x minus m start pause dot x. And we can do the same for dy. dy. Cool. So you can either call this width and height if you like, if you prefer. And then so now we actually want to get the color shader as well. So we need to get the color shader for the rectangle. So we can go auto p color shader is equal to main registry dot get asset manager dot get shader color. Cool. Same idea. If we don't have the color shader, we might as well leave. You know what? We could probably put this up there as well. Not p color shader return. Actually, that's what we're gonna do. So let's get this up here. Make sure we might as well just make sure we have both shaders, and feel free to add in a warning. And we can remove this. Cool. So let's create a color variable that we can change based on which button is pressed. So we'll just say color, and that's going to be color. That's just, we're just going to use the default value, which should be white or all 225s. We can check this out. Yeah. So by default, it's white. Okay. Oh wait, no, it's not. There is no default value here. We should add defaults. Yeah, we should change this. In the vertex, the default is white, but here it's not, but we can change that. 255, add this in. 255, 255, 255, cool. KD, all right. So let's go back to the RectFillTool. So now we want to check to see if the left button is pressed or the left mouse button is pressed. So if B, left mouse is pressed, first thing we'll do here is set the color. So we'll go color is equal to cyan. Actually, we don't need to do that. We can just say, actually, we could probably just do this. And I like this color, so I go 0x70 or 7D, sorry. and then 0x F9, and then 0x FF, and we want it not fully, want it somewhat transparent here. We don't want it full and thick. We want to be able to see the tiles through the color. Cool. Now when it comes to the draw preview, we only want to draw that when we're using the left mouse press, because then it's going to show us which tiles may be dropped. Now we could do it, maybe you could do that as a challenge, see what would be removed. So you'd have to remove the tiles and then put them back when you're done. First thing we need to do there is actually have our batch renderer and draw the preview. Now we have direct access to the batch renderer because it is a protected value. So we need to know what the batch renderer is, so we need to add that in. Let's go up to the top. So we have the Rect batch renderer, and I believe it's the Sprite batch renderer. Cool. Go to the bottom. So we have our batch renderer, and we can say begin. It is not the Sprite batch renderer. What did we call that? We called that, oh, just a regular batch renderer. So the batch renderer itself, we didn't call it a Sprite batch renderer. Sorry about that. And then once we begin, we want to draw our preview. And we're going to be sending in the DX and DY. So that means we have to go back and adjust our preview here because I forgot. This is going to be int DX, or you can say width and height, int DY. Copy this. Send that in there. Cool. Okay, let's go back to the bottom. All right. So right there, now we can do our batch renderer end. MP batch renderer end. Must not have did that, sorry. And we also want to do render. And if we're here, we can just disable the shader. So shader, disable. Cool. So if the right mouse button is pressed, all we need to do in here is go else if is setting the color. We don't need to do anything else. So we can just take this, copy it down, and just change the color values. And this is the color values I came up with for this. So it's highly red, 73, 77, and 100. Now all I did was use a color picker to get these values. You can do the same thing. Cool. So if we made it to here, now we actually want to draw the rectangle, okay? So we want to go P color shader. We want to enable it. So we want to do all of our other drawing first and then do our rectangle on top. So MP shape render, we want to begin. And then here we're going to add a rect, MP shape renderer, add rect. And this takes in there's two overloads. This takes in a rect and a model. So we're going to send in the rect. The model can stay 1.0. So we can just say rect. Bring this down. Let's make this a bit bigger. Yeah. Cool. And we're going to do dot position. That's going to start as the start position. Now this isn't going to work the way that we want it, and you'll see when we actually start drawing. And then we're going to say the width is equal to dx, and the height is equal to dy, and the color is equal to color. Cool. Oh, that can all fit in one line. Perfect. And then we're going to want to do our end for the batch render. So shape batch render end and render. Cool. And then we can disable our color shader. So P color shader, disable. So now that after all this is done, we now need to set the fill rect to what we should use in the create tiles and draw preview functions and remove functions at that. So we can just do this here. So we can go M P tile fill rect position is equal to M start position or start press position. Then the MP tile fill rect width is equal to dx, height is equal to dy. Cool. All right. So we're also going to need a way to reset this. Actually, let's create that now. So let's go back to here, and we can say void reset tile. Let's create this. All right. And all this is going to be is we're going to want to dereference mp tile fill rect, and that's just equal to an empty rect. Cool. All right, so now these three functions are going to be our meat and potatoes. They're basically going to do similar things. Now, I tried doing it in a way where we would just put all the tiles that we want into a vector, so we only had to do this function one time, and then pass the vector, but I found out it was actually slower than doing it this way that I'm going to propose. Before we start, we have to go over a little bit more theory of the situation at hand here. So when we draw or remove or create, we need to be able to take into account certain positions. So we're going to be going up and to the left, up and to the right, up and down to the left, down and to the right. We need to be able to take those into consideration. So let's quickly go over that. All right, so if you take a look at this, this shows our 4 quadrants basically, and it shows a rect that we'd be creating. So say our start point, let's start up here in the top left. So say our start point is here and we go up and to the left. Well, that way we're going negative and negative width, because the way that our graphics works is up is negative, okay? So if we're going up and to the left, left is also negative. We're gonna have a negative width and a negative height. So this side, if we're going up and to the right, we're gonna have negative height and a positive width. And this one, we're going down and to the left, we're gonna have a negative width, positive height. And this one, we're going down to the right, and both will be positive in this case. This case is fine. It's easy to handle. The other ones, we have to change how we are doing our for loop, because we have to account for the fact that these are being negative. Okay, so let's go over what I propose right now. Now we could go use a lot of if statements. So if dx is less than 0, do this, and dy, and do all these 4. However, I came up with a way that I find is, I don't know if it's easier, but it's cleaner to me. So let's do that now. Okay, so the first thing I'll do is the draw preview, and we won't worry about creating tiles yet. So the draw preview has the dx and the dy being sent in. Okay, so we can use this, and the first thing I'm going to want to get is the actual sprite from the mouse tile. So we want to go const auto reference sprite is equal to mp mouse tile sprite. Now it's not going to work right now because we need to get those components, and we can include that ECS and components, and I believe we have all components .h. Cool. Where's our, so we have our sprite, and we're also going to want the transform. Cool. So this still ain't working. It's on editor tile. Yes. So that's not going to work unless we include our utilities. So we can go include editor utilities and editor utilities. Cool. And I think editor utilities already has all components in it. Let's take a quick look. Of course, it doesn't want us to look there, so let's go find it. So here in our utilities, editor utilities already has all components, so we don't need to include it again. We can actually remove this. Cool. And now we want to get the texture from the sprite and make sure it's valid. If it's not valid, we don't need to look at it. So auto p texture is equal to main registry get asset manager get texture, and that's the sprite dot texture name. Cool. P texture. Oh, so if not p texture, we're just going to want to return. We could put an error here, but that's all right. So now that we have the sprite and the transform, we want to actually calculate the sprite width. Now the sprite width is going to be based on the sprite width and the transform scale. So let's add that in now. So auto sprite width is equal to sprite dot width times transform dot scale dot x Now we also have to take into account the width. So that's why this is an int value, because int can be negative. So that handles the fact if it's negative or not. So we need to change the sprite width based on if it's negative or not, okay? So we want to go times, and put this in parentheses, and want to say if dx is greater than 0, we just want to multiply it by 1, dot f. Or you can just say 1 and make this, yeah, we'll just say 1. Or negative 1. So if it's less than 0, we're multiplying this by negative 1. So the sprite width, which is still a float, so we might as well just make these floats. Or we could static cast the whole thing. That's what we'll do. So we'll make this all floats. Dot f. And then we're going to static cast this to an int. So static cast int. Cool. Okay, so what's happening here is we're doing all of our multiplies. Then we're casting it to an int, which won't be good if our scale is like 1.5 or whatever, but if it's whole numbers, it works fine. We probably will change that, but we'll see. Let's get this to work as is right now. Or you can keep it so your scale is always within whole numbers. And we want to do the same thing for height. So change this to dy. Y. Height. And then sprite height. Cool. So now that we have that, we can actually start doing our nested for loop. We were going over this before, but it has to be a little bit different. The one I showed you in the slides only cared if they were both positive values. So we can actually use the same ternary operator inside of our for loop to decide how to do our checks. So we want to go for, and we'll do our rows first, which will be our y. So int y is equal to 0. Do our check. If dy is less than or is greater than 0, that means we're positive, right? So if dy is greater than 0, we're positive. We want to say y is less than dy. Else, we want to say y is greater than dy because it's going negative. So as long as y is still greater than the negative value, we're okay. Cool. And then we just want to go y plus equals sprite height. So this will work because if sprite height is a negative number, we're just going to be subtracting that value. So you're adding a negative number, which is a subtraction. Cool. And we can actually just copy this line down, put it inside there, put it in here, and let's change our value. So it's the same idea. So x dx x dx x dx x width. Okay, does that make sense? So what this does here, it compacts the code, and instead of having a bunch of if statements, feel free to break this up into if statements if you don't like ternary operators inside of your for loops, okay? So now we actually want to add these tiles to the batch renderer to be drawn. So what we want to do is get the position. So you want to go glm vec for tile position. And that's going to be m start press pause dot x plus x, and then do it for y. Then we're going to have our sprite width. Now this could be a negative number, so we'd have to multiply it if it's negative, or we can just go sprite dot width times transform dot scale dot x, and we can do the same for y and height. Cool. And now we want to get our UVs, so we can just go glm vec for UVs. And that's just sprite dot UVS dot U. Copy this. Dot V. UV width, and UV height. Cool. Now that we have that, we can actually add that into our batch renderer. So we're going to go MP batch renderer, add sprite, tile position, UVs. Now we need our texture ID, P texture, get ID. And then we're going to have a layer, and we can make up here. So up at the top, let's make a quick const expr value, const expr, and preview layer. And that's going to be 10. So const expr int, sorry, preview layer 10, copy preview layer, let's go back down, paste that in. Then we want to do our GLM mat4 1.f, then our color, sprite.color. So I'm thinking about moving where the mat4 is in the matrix 4 in this, because usually it's not going to change unless we want it to change. Color should go before that, so we can because this is already default, we may change color before we change this. So we might change that later on. It would probably make more sense to have it changed. So there's that. And you know what? Let's actually see if this works, because we did a lot of code without testing it. So in order to see if this works so far, we actually need to go to our tool manager and add this in. So if we go to toolmanager.cpp, we need to actually add in our RectFillTool. So include RectFillTool.h. And right where we're adding these in, right here. So we actually don't even have to do this. We can actually just take this, paste this in here, get rid of this. Cool. And we can copy this line down. And this is going to be our RectFill tile. And it's going to be our RectFillTool. And we're going to change our tool, the current tool that's active, to the RectFill tile. Cool. Now this should be the only one that we have active right now. Let's run it and fix any bugs that we may have created. Okay. Okay, so we got to do a couple things to get this to work. Move this to tiles, scenes. We got our scene in, run the scene, get some tiles, get the tile set, get the hill tile, and let's try it. Awesome. So see how it's filling it in? Now we're not drawing, but look at that. You see how it's off? That's what I was talking about with the position. So we're going to have to fix that. Going down on the angle, that's fine. We're still building it this way, it's fine. But we got to see how it's off by one tile each. And if we go down this way, it's off that way. If we go this way, it's off that way. But that's fine. We'll fix that shortly, but we're getting our preview, and that's what we wanted to see. Let's see. So we're drawing our red. That's exactly what I want. But you see how the mouse tile, like the mouse tile here that's following the mouse, is outside of the rect? Well, we don't want that. We want it to actually be inside of the rect. So we have to offset it a little bit, because that looks funny. You know what I mean? We want to offset it, because right here we can get it that way. But if I go here, it's all offset funny. So I can't do a whole screen because it's offset. We don't want that. So right now I need all those. See how there's these two lines that with no tiles in it? We need to shift that up and work on that. So let's do that now before we continue. So let's stop this. And the place where we're going to do that is actually in our draw function. So let's go back to RectFillTool. Go back to the draw function. So we have our dx and our dy. Now I'm going to want to offset this a little bit based on the sprite. Okay. So right here, we want to offset it. So I want to go const auto reference sprite is equal to mp mouse tile sprite, and we'll get the transform, and get the transform. So we want to basically do the same thing that we did above and get the auto sprite width is equal to sprite.width times the transform .scale.x, and we do the same thing for height and y. Cool. So now that we have that, we want to check to see if dx is greater than 0. And if it is, we want to add the sprite width to it. If it's less than 0, we want to subtract it. So we basically just want to shift it over. Okay, so I'm going to go dx plus equals dx greater than 0. If it is, I want to add the sprite width. If not, I want to subtract the sprite width. That will shift it over one whole tile. Okay, we want to do the same for height. dy. Cool. And then I actually want to get a new position here. Okay, so I want to say auto new pause x is equal to m start press pause dot x plus dx is greater than 0. We don't want to add anything, but we want to add the sprite width if it's not. So we want to shift it over. So if it's greater than 0, I don't want to do anything. Okay, I just want to add 0 to it. But if not, I want to shift it to the positive direction by one tile. So I want to do the same thing for the height as well. dy. Y, new pause, y. Cool. And then we come down. And right here, we're setting our position to start press pause. Well, this is actually going to be our new press position. So we can go new press or new pause x and new pause y. And we can copy this as well and put it here. Awesome. So that should help. Let's see how that works. Run it. So we want to do the same thing. Tilemap Editor. Open our scene. Run it. Hill tiles. Draw it. Oh, looks like everything's good that way. All right. Looks like we're good in all directions. Can I fill the whole thing? I can, if we don't go too quick. Cool. Yep, can fill the whole area. Awesome. That's exactly what I was trying to do. So we want it to be on the inside. You see how it's on the inside now? And that's where you want it to be. So now it's on the inside of our rect, and it's doing the controlling for us. Awesome. So we got our preview going, and now we can actually do the fill. So we're actually creating tiles. So let's do that now. It's basically the same thing. So let's get out of this. All right. So let's go to our create tiles in here. So we have our create tiles. So what I'm going to want to do is do basically the exact same thing as the draw preview. So we can just grab the whole thing. Actually, let's grab all of this, and we'll just discard what we don't need or add what we do. So we paste that in. So this has no concept of what dx and dy is because we're not setting that in. So what I would like to do here is just say const int dx is equal to static cast int mp tile fill rect width. I do the same thing for dy and height. dy. Cool. So yeah, see how it's basically all the same thing. So let's actually just get rid of all this in here and go to our create tile tool. So where's our create tile tool? Here. Go to our create function, and we can grab all this stuff out here. We don't need the mouse chords here, but we'll grab this. We'll grab everything anyway because we're going to be needing all this stuff. So let's grab this, go into our rect fill, and paste that in. And let's make the changes that we need. Okay, so we're not going to need the mouse chords here. Let's get rid of that. And the first thing I'm going to do is get the new tile position. So I want to go glm vec2 new tile position. And that's going to be the m start press pause dot x plus x M start press pause dot Y plus Y. Cool. And we can send that new tile position in here. So new tile position. And if there's already a tile there, we're not going to want to do it. So if it returns an ID that's not ENTT null, we just leave. Okay. So we want to do the same thing and create a tile. So we use the create tile entity. What's changed here is it's not mouse transform anymore like this. Okay. What we want to do, well, we can do this if we want. And we can, instead of setting each one, there's a few things we could do. We can say auto reference new transform. And so we're setting it to the tile transform. Well, we don't even need that because we already have this. This is a bit cleaner. So we already have the we're already doing that up here, right? So we're setting it to the transform here, and we're getting the reference back, and we can change the position to the new tile position. Cool. And for this one, all we have to do is send in the sprite. We don't even need this here. We can just say sprite. No magic needs to change for that. Then there's the colliders, all this. We're not doing this stuff right now. We're not worried about it. And that's it. That's all we need to do for our create function. And this should work for us. So let's try it out and see if it works. Okay. So assets, Tilemap Editor, scenes, drag our scene in. We have our scene. Run the scene. Hill tiles. And drag and bam, look at that. We created our tiles. Perfect. So let's see, it's not going over top. It's not doing there either. It should have filled in there. I'm not sure why it's not filling that area. So I missed something that we're going to have to figure out. Let me see if I can fill it with this. So yeah, so for some reason, it's not filling in this area. The remove's not done yet. So we're missing something here. And I think I know what it might be. Let's see what we missed. Okay, I think I know what the problem is. We skipped something here. So right here, we need to actually reset our tile. So we're starting back from fresh. Let's see if that works. All right, try this again. And we'll drag it. Awesome. Let's do the whole area. And it still didn't work perfectly. This is weird. Awesome. So we have to do more troubleshooting, so it wasn't just that. Let's put in a different scene just to make sure. Let's do the whole area. So that time it worked on that scene. I'm confused now. Let's run this again. Weird. Just released, just released. Let's make sure we're doing everything correct. That looks correct. I'm going to try it one more time. Sorry, guys. Oh, yes. I know the problem. I probably, yeah. You know what? You guys probably caught that. So you see what's happening here. So the reset, we had to do the reset thing, but it doesn't matter as much as this. So we want to continue, not return. So now it should definitely work. That's silly. Sorry about that. All right. Scenes. This one. And we'll just do this one. Then we'll just go over top of it. Just go around the edge. It should only be around the edges. Awesome. Look at that. That's exactly what we wanted to see. Cool. And then we'll just do the whole area. Actually, let's do it with signs. And we'll fill in the rest with signs. Awesome. So that's working exactly how we wanted it to work. So now we got to do the remove function. So it's going to be, again, the same thing. Now, I realize we're doing this over and over again. And I tried to do it where we're doing all this like 3 different times, but we're not all doing it at the same time. You know what I mean? And I tried to do it with get tiles, and it was actually slower to do this and put everything into a vector and then just draw it the other way. This actually ran faster, so. But anyway, let's copy all of this. Actually, let's get this one because there's less in it. No, actually, let's get this one. Let's get all of this again because we're going to need it for the remove function. Paste that in. And in here, let's go and take out all of this. We don't need any of this. Cool. And what I'm going to want to do is eventually we're going to have to add in the undo redo functionality. So right now I'm just going to want to get a set. So std set of std uint 32 t, and these are going to be the entities to remove. Okay, and here we're going to want to do our check for tile, so we can grab that function right here, bring this in, paste the check for tile, and we're going to want to do it a little bit differently. So we want to go glm vec2, then it's going to be, we need to get the start pause, so m start press, not state, start press pause dot x plus x m start press pause dot y plus y. And this one we want it to not equal to null. And if it's not equal to null, we're going to want to add it in. So entities to remove dot insert id. Cool. And now we want to loop through all those IDs and just kill them. So we just go for auto ID entities to remove, and we're going to say entity removed remove tile create entity. Now we're going to send in the ID because we created that other function where we can create an entity from another entity. Now this doesn't actually add a new entity, it just creates an ability for us to grab the entity, okay? And then we can just say removed tile dot kill. Cool. And that should work for us. So what's happening here is we're just grabbing our entity and removing it. We don't need the texture here because we're not using it. Cool. We only really care about the ID. Okay, and let's run it. So we go to Tilemap Editor, load in our scene, start the scene. Let's just fill out the whole area. We can fill it with hill tiles. Let's just do this. Grab it, fill the whole area. and we'll do the right click. Bang, look at that. We can go any direction and it pulls it out for us. Grab some water, place it in. Look at that. Much faster than before. That's great. So that is basically it. I think we covered everything here. We're now able to do that. We're now able to use our Rect tool and automatically create maps much faster. We can just delete all these if we don't want them. Just delete the whole lot. Cool. And start fresh. So now you can create faster maps than you wanted before. Now, later on, we're going to be changing the layer. Right now, this is all on one layer. So we're creating it on a layer, and we don't want that. We want to be able to adjust the layer based on some different parameters that we send in. We also want to be able to add the collisions and all that stuff, but we'll get to that. It's important, but not as important as some other things. We need to be able to serialize the map. We also need to be able to load and open the map. So I think that's what we're going to get into next. We're actually going to start getting into file dialogs and how we're going to do that. I was thinking about starting to use NFD extended to do that. So if you want, there'll be a link in the description. Take a look at that. See if you can implement it yourself. Or we could use IamGUI dialog or something like that. I'm still up in the air of what I want to use because I want to make this cross-platform, and I don't want to do all of the dialogue stuff myself. I'd rather it all already be done. Like, we can do it and we can go through that process, but that'll just take forever, and I'm not interested in that at the moment. I'm more interested in just getting this to work as fast as possible. All right, so that's it for this video. If you have any questions, please leave them in the comments below. I'll make sure to get back to you, and that's it. Take it easy.